in this video I will explain you conservation of momentum. I will explain definition and its derivation. Now, what is conservation of momentum? Like we have studied conservation of mass, conservation of energy. In the same manner, there is a conservation of momentum. Like, what is conservation of energy? Energy can neither be created nor be destroyed. In the same manner, what is conservation of momentum? Momentum can neither be created nor be destroyed. Suppose now we have two things. Suppose we have two balls and these balls have definite mass. So before collision, whatever there will be momentum, the same momentum will be there after the collision. So what is the definition of conservation of momentum? That is, the total momentum before collision is equal to total momentum after collision. It means, like if we are taking, suppose the two balls are there, one ball has momentum 4 and the another ball has momentum 6. So what is the total momentum? 10. So this total momentum 10 will remain same even after the collision. This is called conservation of momentum. Now I will explain you its derivation with the help of this example. Suppose we are taking the two balls. One is this ball 1 and this ball has mass what? m1 and it is moving with the velocity what? u1. This will strike with the another ball that has mass m2 and it is moving with the velocity u2. This is before the collision. Suppose if we are taking its momentum was 4 and its momentum is 6. So what is the total momentum? 10. Now when they will collide with each other, this is ball 1 and this is ball 2. This ball m, which has the mass m1, it has more velocity. It means we can see u1 is more and u2 is less. Now both will collide. It means ball 1 will collide with ball 2. And when both will collide, then what will be there? The both will apply the force. It means ball 1 will apply force on ball 2. That's why it is written here F12. And the ball 2 will apply force on ball 1. That's why it is written here F21. Now when they will collide, they will also move. After collision, they will also move and the mass will remain same. So its mass will remain m1 and then it will move with what velocity now? v1, because u1 will change to what? v1. Then this is the ball m2 and that will move with the velocity what? v2. Now their momentum, the mass will remain same but the velocity will change. But even when the velocity will change, then the total momentum of both the balls will remain what? 10. Like in this, what was the total momentum I told you? It was 4, it was 6. So what was the total momentum? 10. Now in this case, the mass will not change because both were colliding. So it will not change, but what will change? Velocity will change. But the total momentum will remain same. That will remain 10. Now its derivation. Now we have studied according Newton's third law of motion. What is there? F1 is equal to minus F2. It means whatever force will be applied by ball 1, that is F1, same force will be applied by ball 2, that is F2. And we are putting minus sign here because both are acting in which direction? Opposite. And both will have equal magnitude. Like I told you, every action has equal and opposite reaction. So F1 is equal to minus F2. And according to Newton's second law, you have studied F is equal to m into A. So here for F1 we will write m1 A1 is equal to, for F2 we will write m2 A2. Now what is the formula of A1? A1 is V1 minus u1 upon t. Now you can check m1 v1 minus u1 upon t. Now we will write in the same manner is equal to minus m2. Now we will write formula of a2 v2 minus u2 upon t. Now we will writing same t here. We are not writing t1 and t2 because both will collide in the same time. Now we will open this bracket. Before opening we will cancel the t and then we will write m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2. And when this minus sign will go here, what sign will come? Positive. And when this minus sign will go here, what sign will come? Positive. Now you can check m1 v1 plus m2 v2 is equal to, what is coming here? m1 u1 plus m2 u2. So if you are writing here, if this will come here and this will be coming here, same thing will be there. Yes, if I am writing x is equal to y, so we can also write y is equal to x. So same thing can come here, or m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this was the derivation of the conservation of momentum. Now this is the total momentum before the collision, and this is what? Total momentum after collision. ये क्या था? This was for the ball 1 and this was for ball 2 for before the collision, and this is what? Momentum of ball 1 after collision, momentum of ball 2 after collision.